Good morning, YouTube. What's up, everybody? So we're on part 4 of reviewing the SHSAT handbook from 2020 and the grade 9 examples. I'm Greg from Greg's Tutoring, NYC@gmail.com. Let's just jump right in here, guys. All right, so we're up to question number 10. I'm looking at some soccer data. So in this, I told you guys I look at illustrations first. It turns out there's no narrative before this, so it just jumps into it. So we have 4 players, the number of seasons that they played soccer, the number of goals they scored, I guess, per season. And I don't know what it's going to ask us about this. So sometimes you need to add things up. But you can just kind of look at things and just try to analyze it without reading the question or without reading the answers. It seems like everybody scored a goal. Everybody scored a number of seasons. The number of goals scores is higher than the number of seasons played. So there's some multiple there, perhaps. And there may or may not be a pattern there across the numbers if we order them. All right. And everybody has about 2 times the number of goals per season played. So it's about season played times 1.75 or something. Although Porter has about the same thing too. And Jasmine has exactly 1.5. All right, so I'm over analyzing the data at this point. So then we come in, let's just make sure we're live. Yes, we are. The data in the table shows the number of seasons some players on a soccer team played versus the number of goals they scored. Which conclusion is supported by the data? Okay, so let's try to scroll this up a little. E, there are multiple outliers in the data. Okay, the number of season goes from 1 to 6, so there's nothing too freaky there. The scores goals scored. Whoa, I said that weird. Goes from 3 to 10. There's nothing too weird there. The 10 is kind of out there, but it's not out there to the extreme of being esoteric. So if any number is out there, it would be the 10. So that might be an outlier. We're going to have to look, but I doubt it. It just says no. So that's number 1. Number 2 is it says outliers. There are multiple outliers. So if there's any outlier, it would be Porter. Just 1. There wouldn't be 2 of them. So why don't we bring our data in some sort of organized form. Isabel is the one who's out of place, but let's put it in from lowest to top order. So if I go Colin, Jasmine, Colin, Isabel, Jasmine, and then Porter. So Colin was 1, 3. Isabel is 3, 5. Jasmine is 4, 6, and Porter is 6, 10. There seems to be a flow. This number's going higher, and this number's going higher. Again, nothing seems too freaky here. This column here is about 1.5 or 1.75 of the first column, if we consider this X and this Y, if you will. Okay? In fact, what we can do is, why don't we create a visualization of this as in a coordinate geometry? Let's see, they're all positive. So if we make something 10, that's about 5. That's about 5. So that would be 10. That would be 10. Okay. So Colin is 1, 3. So Colin's about there. 1, 3, Colin. Okay. Isabel is 3, 5, so about right there. That's Isabel. Porter is 6, 10. And what do we miss? Jasmine is 4, 6. There's kind of a line of best fit here. All right. So this seems to be ordered. Again, Porter is over here, but you could see that on that line, so to speak. and it's not like it's 60-10 or something like that. So nothing is out of where it needs to be here. So it says E, there are multiple outliers on the data set. No, neither view of this really shows that. Okay, and my gut feeling when I was looking at it didn't seem to think anything was too wrong. Everything's pretty par for the course. E, there is a positive association between the seasons played. So this was the seasons played, and this is the goals scored. So there's a positive association. As the number of seasons go, the scores get higher for everybody. Okay, first of all, this column was larger, but if you played more seasons, you got more goals. You played more seasons, you got more plays. This guy played the least number of seasons, he got the least number of goals. Okay, so it wasn't even necessarily about best players for this group of 4. So F seems to be correct. Okay, G looks like it's exactly the opposite of F. So if you know how to read these, then it's either F or G, depending on how you look at it. But it's not G. There's not a negative association, right? As the number of seasons increased, so did the number of scores. Okay, and then H fell off the screen here, and it says there's no association. Well, it looks like there is one, so it's F. Okay. Okay, 11 is we have 0.25 times y plus 8 equals 15. All right, so what we need to do is do our normal distribution property. So most kids are going to do the 0.25 y plus 0.25 times 8 equals 15. And this starts going down a rabbit hole because we have ugly math. All right? It's not that you won't get the right answer. You will get the right answer. But it's going to be a tedious process. What you want to find out is this is the same as a quarter. So we have 1/4 y plus 8 equals 15. And then it just becomes easier. So there's a quarter here. We're not going to do the distributive property. So we're not, up here we left it as 0.25 and we distributed. Here we're moved it to 1/4 and we're going to ignore that there's distributive property here. And we're just going to multiply both sides by 4. So we can get y plus 8 equals 60, and then y equals 51. Is that the right answer? Where are the answers? What question number is this? 11? 11 is D, and I made a mistake there. It should have been 52. Okay? So this is something you could do in your head. In fact, by putting it on paper probably gave me the wrong error. So there you go. So sometimes you want to do the conversion. You don't want to leave things as decimals. All right? And you certainly didn't want to divide both sides by 0.25. If we did that, that would have just been ugly math. And you would have had 25 going into 1500, something like that. And you're just going in ugly places, all right? And then when you get your answer, you can feed it back in, right? So if I go back to the original problem, so if I have 52 plus 8 is 60, 60, a quarter of 60 is 15, all right? Always feed your answers back in. That's your double check, all right? Okay, 12. So 12 is, get a scrap paper here. What is the volume in cubic inches of a beach ball with a diameter of 24 inches? Okay, so we have the grok out of here, that is the so-called perfect beach ball, and it's round, and therefore it's a sphere, right? So what is the volume of a sphere with a diameter of 24 inches? So we go visual. The diameter is 24. Okay, and it's 3-dimensional. So if the diameter is 24, that means the radius is 12, right? The next thing we need to do is the formula. So the volume of a sphere is equal to 4/3 pi r cubed. So we're going to have 4/3 pi 12 cubed. Okay, so we have this where we can do 12 times 12 times 12, and that can get nasty. Okay, so we all should know that this is 144, and then it's just a matter of doing the other math. But we also notice we still have the 4/3 pi stuck in there. Okay, so what I can do is, because I need to do this computation 12 times, 144 times the 12, it's still multiplied by the 4/3. Let's see what we can cancel out. So the 3 goes into here 4 times, and then we have 4 times 4, and that becomes 16. Okay, so we get 144 times 16. 64 is 24, 2, 28, 2, 8, and then it's 4, 4, 1. So we get 4, 2, 1, 9, 3, 2, 2, 3. Whoops, what did I do here? 24, 7, 6, 0. So we get to 2304. Okay, so that would be each. We can also confirm here. We know at the point that even if we left this as it was, if we use our number smarts, first of all, it was 144 times 16. So 6 times 4 is 24, as we found out here. That's the only answer. D is the only answer with 4 as its last digit, as it's in the one place value. So we don't even have to do this computation if we don't want to. Okay, we can also do estimation. So we have 100 and something times 16. That's already 1,000. That's 1,500 already. And we're not even looking at the 6. So if we did like 150 times 10, we're already at 1,500. So we're past the E, F, and G, and the answer has to be H then. All right? So there's in a way we didn't even need to go past the computation. We didn't need to do this. And even at this point, once you got to 144, you knew you were done, because it's already times 12 again of that, plus 1 1/3 over the year. So you know your answer's past the 576, way past the 576. Once you do the 12 times 12, you're like 1/3 of the way to the 576 already. So you should know that you're cool there. So again, we're using estimation and rounding to confirm our answers as well. All right. So 12 is the kind of problem you can't really feed the number back in, because how do you feed the 2304 back into the original question? So that's one where you kind of want to look for alternate solutions, and this is just the volume of a sphere, so there's not really an alternate here. So you just want to make sure your number sense is right. Right, I made my digit wrong here, and it's just and by the way, as I keep saying, it's not so much that you made a mistake. Every tutor makes a mistake with every student. It's a question of, can you see it right away, and can you fix it right away, and then you mathematically savvy enough to detect it. So we all make the silly errors. The question is what we do about them. All right, so that's 12. So 13. So 13 is kind of weird. Let me write 13 down. So we have 5 less than square root of n less than 6. So let's take a sidebar for a second. If I had x squared minus 1 equals 8, what I would do is add 1 to both sides, get x squared equals 9, and then take the square root of both sides, get x equals 3. All right. So the goal is to get the symbol by itself, and then when we have a weird operation like squaring, or absolute valuing, or different things like that, we still do the opposite operation, because this is kind of boxed into a corner now. It's square. How do we isolate x? There's no coefficient. There's no multiplication to it. There's no divisor. We already got rid of the thing that was subtracted from it. So we always have to, when we get the symbol by itself, as isolated as we can get it, we need to do the reverse operation. So if it's x squared, the reverse operation is the square root. So a lot of kids start melting here, and they think they're trying to put 5.5 here, because most kids have never seen anything like this before. So that actually, for 13, this is actually a hard question, because it throws a lot of kids like, whoa. And even though they could follow this is so far into some kids, they haven't a clue. And I work with too many kids on a problem like this. So they're going to originally think B. But if you read the question, it doesn't say what is N. Because really, we're talking about 5.5 being the square root of N. Right? Whatever this value becomes, not N, the square root of N, whatever that value becomes, that would be 5.5. But then it asks us how many integers satisfy this condition. And you're like, integers? An integer can't fit in here. If it's between 5 and 6, there's no integer. So a lot of kids just melt on this question. And what we need to do is the same thing we did over here. We do the inverse operation when we get the symbol down to itself and any other operation upon it. So let me write this over. So if I have 5 less than the square root of n less than the square root of 6, this is the square root of n. So to get n by itself, I need to square it. I need to take each term now and square it. So then I get 25 is less than n is less than 36. All right? And then we need to do the subtraction. 25 and we get 11. The question is that the answer? Because if I have 3 minus 1, I get 2. Right? But there's only one thing between the two of them. So that we should subtract off 1 here and get 10. And you can double check it. We get 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. Okay? Did I just do that right? Yeah, it's 10. 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. We want to go to 35. We don't want to go to 36. Okay, so we get 10. All right, guys. So I went over the 2020 grade 9 math examples now. So I'll put an end to this part of the series. I have to agree that these questions didn't cover the full gamut of what the grade 9 SHSAT math part is about. In fact, some of them were quite simple, and not only were they simple, they really just tested your knowledge at almost a state test level. So I'm disappointed in this group of examples. Nonetheless, you still need to know that core knowledge, and if you can't solve any of these, then you can't solve them that more complicated. You can't solve them as deeper word problems. You can't solve them when they have little tweaks in them. Some kids call them tricks and traps. I just think they're math examples. You just need to know what they are. So push forward past these examples. There really wasn't anything on coordinates. It did the scientific notation thing twice. But you know what? Some of these examples are exactly where you need to get your points on. So many kids forget things like, it could be a question, there was the question about rational numbers, I think. Question number 3 was, there could be another one like, which number is not composite or something. Everybody like, oh my God, what's a composite number? Or there could have been a deeper one involving coordinate geometry, a translation on coordinate geometry. We're going to dilate something or rotate it or something like that. It could be another one involving supplementary and complementary angles. Or it could give you a figure where you have to determine what's the angle in a regular figure of one of those. These are all terms like what's a regular figure. You need to understand it means all the angles. It's a polygon where all the angles would end up the same, and all the sides might have equal length and so on. So there's things like that. Also on that note, there's things like symmetry and congruence, and so many places this could have gone. Linear equations, solving simultaneous linear equations, and things like that. So, all right. Hopefully this is helpful to you guys. Please subscribe to the channel. I'm going to be doing more of these. Not necessarily about this part anymore, but other grade 9 and grade 8 things, including ELA stuff. And then I'm going to also cover some general things, I think, dealing with how to get yourself psyched. Not just psyched, but how to move yourself into getting a top score. One of the issues, particularly with the grade 9 SHSAT, is that not only is it harder than the grade 8 SHSAT, but the dynamics are completely different. There's less students who take it, but the stakes are higher because the number of seats in incoming grade 10, which is what you will be taking this test for, is statistically almost zero. So, some schools may only have 2 to 5 seats. Brooklyn Tech traditionally has the most, which is about 35, but it's still not an awful lot. And even though there's not 30,000 kids vying for the grade 9 spot, there's a few thousand. So the stakes get even higher, and you really want that. And for the kid who wants to get a seat at Stuyvesant, which normally has about 5 seats, you have to be out there. You really have to be out there. And traditionally, the DOE doesn't really release the cutoff scores, but people are able to determine them through other means. I have those numbers, but they don't release it at all for grade 9. So that becomes a horrible situation. So normally the rule of thumb is to take a grade 8 SHSAT score and add maybe 50 or 60 points to it to really get that. So if you're looking at cutoff scores, either last year or historically over the years, and again, I have all that kind of data. In fact, I have a software suite that is able to analyze your testing process, your scoring, your grading, through a whole procession of stuff as you go through a practice test and so on. And it also gives heuristics, which is advice on what to study and things like that, and even how to study. So I'm going to tie all that up and present parts of that, not the scoring program, but some of the ideas behind it, some of the videos, because a lot of you guys, at some point you should probably hire external help because it's just worth it. There's so much mythology about the SHSAT, and there's so many kids who are working their butts off, but they're working their butts off for the wrong reasons. They're studying for something else. They're not studying for the SHSAT, and it's a shame that that's the case. So I'll do some more about those. All right, anyway, I'm past grade 9 math. I wish you guys a great day. Peace out.